Hello students, today I am going to explain you chemical bonding in one shot. Right? Kindly watch this video till end. So you will get 100% knowledge, I promise you that. And you will get lot of logics and tricks in between the video. Kindly watch the video till end and you will be able to identify what is ionic compound, what is covalent compound, what is coordination covalent compound by this one video. Right? Now I am going to this chapter, chemical bonding, atoms involved in bonding to become themselves as stable. Atoms involved in bonding to make themselves as stable. Right? So generally chemical bonding is of three types. Right? Three types: ionic, covalent. Right? The second one is covalent. The third one is coordinate covalent. The third one is coordinate covalent. Right? So first I will explain you the ionic bond formation. First I will explain you the ionic bond formation. Right? Ionic bond formation. So to form for the formation of ionic bond formation, you should know three important things. For ionic bond formation, so before I am explaining ionic bond formation, so I want to make sure you know the three things. The first thing is atomic number of the elements, right? Atomic number of elements 1 to 20, right? So you should know atomic number of the elements 1 to 20. The second point you need to know is the electronic configurations 2, 10, 18 are stable. 2, 10, 18 are stable. What is this? I will explain you. What is this? I will explain you. Now you remember that electronic configuration 2, 10, 18 are stable, and ionic bond happens between metal and non-metal. Ionic bond happens between metal and non-metal. And what is metal and what is non-metal? I will give you a trick. If you take NaCl molecule, the first species always comes is the metal. The first species which comes always first is the metal. The second species is non-metal. The second element is non-metal. If you take magnesium chloride, so what is the first species? Magnesium. So this is non-metal. Magnesium is metal. Cl2 is non-metal. If you take MgO, right? So I told you the first species is always metal, the second element is always non-metal. Here magnesium is metal, oxygen is non-metal. So you should remember these 3 points to understand the ionic bonding. The first point, you know atomic number of the elements 1 to 20. The second point, you know 2, 10, 18 are stable electronic configurations. The third thing is you should know ionic bond formation happens between the metal and the non-metal. The first element is the metal, the second element is the non-metal. And coming to the ionic bond, so ionic bond happens by the transfer of electrons, right? Ionic bond happens by the transfer of electrons. So in ionic bonding, there is transfer of electrons is involved. In ionic bonding, there is transfer of the electrons involved from metal to non-metal. From metal to non-metal, right? From metal to non-metal. In ionic bonding, there is a transfer of electrons from metal to non-metal. Right? Now I am going to show you, right, how the ionic bond formation happens in NaCl. Now I am going to show you how the ionic bond formation happens in NaCl. Right? Before that you should know, so I am writing over here 2, 10, 18 are stable electronic configurations. Now I will show you the formation of ionic bond in NaCl. First write metal. Right? What I told you, metal always lose electrons. So what is the atomic number of sodium? 11. Atomic number of sodium is 11. Atomic number equal to number of electrons and number of protons for a neutral atom. Atomic number equal to number of electrons and number of protons for a neutral atom. So sodium has 11 electrons. So what is the stable configuration? 10. What is the stable configuration? 10. So to become stable, it is going to lose 1 electron. It is going to lose 1 electron, and now it has 10 electrons. So metal loses electrons, right? So this losing of electron is called oxidation reaction. So metal undergoes oxidation reaction and loses 1 electron. Next, coming to the sodium, right? So if you take chlorine atomic number is 17. Coming to the chlorine atomic number is 17. So what is the nearest stable electronic configuration? 18. What is the nearest stable electronic configuration? 18. So chlorine will accept one electron. Chlorine will accept one electron and it will become Cl minus. Gaining of the electron is called reduction. See here, metal is losing electron, non-metal is gaining electron, and electron transfer is taking place from metal to non-metal. See, the electron released by the sodium is taken up by the chlorine. So electron transfer is happening between the metal and non-metal, right? Electron transfer is happening between the metal and non-metal. Now we have a positive charge and we have negative charge. So there is a formation of electrostatic attraction. So in such a way, ionic bond will be formed. You can also show like this. So one electron from sodium, right? One electron is sodium is transferring to chlorine. One electron from sodium is transferring to chlorine and they are becoming ions. Ionic bond, they are becoming ions. So there is electrostatic force of attraction developing between them. In such a way, ionic bond is in NaCl is forming. And we can give one statement also here. Elements with 1, 2, 3 valence electrons, right? Give positive ions. So I will write positive over here, right? Give cations. I will simply write cation means positive ions. Elements with 1, 2, 3 valence electrons. What is valence electron? If you write sodium electronic configuration, so what is the sodium electronic configuration? Klm281. So the outermost shell is valence shell. Here what is the outermost shell? M is the valence shell. So in M, how many electrons are there? 1 electron. So 1, 2, 3 valence electron means it forms cations. 1, 2, 3 valence electrons means it forms cations. So sodium is forming cation, right? So if there are 5, 6, 7 valence electrons, it forms anions. If there are 5, 6, 7 valence electrons, it forms anions. If you take chlorine, right? Chlorine atomic number is 17. Its electronic configuration is 17. Its electronic configuration is 287. In valence shell M, there are 7 electrons. As I told you, 5, 6, 7 valence electrons means it forms anions. So chlorine is forming anion, right? In such a way, we can explain the ionic bond formation in sodium chloride, right? I will explain you in magnesium chloride, right? How ionic bond formation, right, will take place, right? Observe carefully. Now I am explaining for magnesium chloride, right? Magnesium chloride, I will explaining you. Magnesium chloride formula is MgCl2. Magnesium chloride formula is MgCl2. Okay. In MgCl2, magnesium, right? Magnesium atomic number is 12. First write the atomic number. Then how many electrons is going to lose, you need to identify. How many electrons is going to lose? How can you identify? It is 12. Its nearest atomic stable is 10. So it's 12. Its nearest atomic stable is 10. By losing 2 electrons, right? By losing 2 electrons, it becomes stable. By losing 2 electrons, it becomes stable. Now there are chlorine we have each chlorine take up one electron. In sodium chloride we have seen. In sodium chloride, while explaining sodium chloride, I have shown you one Cl take one electron. Here there are 2 chlorine atoms. So it will take 2 electrons. So it will become 2Cl minus. We have Mg plus 2 over here, 2Cl minus 2 over here. So I will write Mg plus 2, Cl minus and Cl minus. So there is a electrostatic attraction developed between them. We can also show this magnesium, right? So one electron will be taken up by one chlorine, another electron will be taken up by another chlorine. We can also represent in magnesium there are 2 electrons, one electron taken up by the one chlorine and another electron will be taken up by the another chlorine. In such a way, we can show the ionic bond formation in magnesium chloride. I think understood. First magnesium metal. First this is the metal. First always will come metal. Then this is the non-metal. Right? Metal will lose electrons. Non-metal will gain electrons. How many electrons it going to lose? That we can know from atomic number and the stable number, right? So there is the difference between the atomic number and stable number is 2. Nearest stable number is 2. So these 2 electrons it is going to lose. Then non-metal, so its atomic number is 17, right? So its nearest is 18. Its nearest is 18. So by getting 1 electron, it will become 18. There are since 2 chlorine atoms, by taking 2 chlorine atoms, right? So it is becoming 2Cl minus. Now we have positive and negative charges. So there is electrostatic attraction develops between them, and this is a formation of magnesium chloride molecule, right? Now I will show for magnesium oxide, right? I will show you for magnesium oxide. If you take magnesium oxide, I will write over here magnesium oxide, right? So this is metal. This is metal. This is non-metal. This is non-metal. So magnesium atomic number is 12. It is going to lose 2 electrons. Right? Magnesium atomic number is 12. It is going to lose 2 electrons. In such a way, it becomes stable. Right? So now oxygen 8. Oxygen 8. What is its nearest atomic number? 10. What is its nearest atomic number? 10. So it need to gain 2 electrons. It need to gain 2 electrons. It is going to get these 2 electrons. It is going to get these 2 electrons which are released by magnesium. And by taking 2 electrons, it becomes O2 minus. By taking 2 electrons, it becomes O2 minus. Now we have positive and negative charges. There is electrostatic attraction develops between the positively charged magnesium and negatively charged oxide ion. And negatively charged oxide ion we can also show in such a way, right? Magnesium 2 electrons. Magnesium 2 electrons will be transferred to magnesium 2 electrons will be transferred to oxygen atom. Magnesium 2 electrons will be transferred to oxygen atom. In such a way, we can explain the ionic bond formation in sodium chloride or magnesium chloride or magnesium oxide. I am giving you homework, right? You can try for calcium oxide. You can try for calcium oxide. Okay. Then, while coming to the properties of the ionic compounds, right? While coming to the properties of ionic compounds, okay, no problem. I will explain you calcium oxide also, right? I will give you another thing as a homework, right? So, do the homework for, I think, calcium chloride, right? You can do this as homework. You can do this as homework. I will explain you for calcium oxide also, right? Calcium. Here Ca is metal, O is non-metal, O is non-metal. Calcium atomic number is 20. Calcium atomic number is 20. What is its nearest atomic number? 18. So what is the difference? 2. So it is going to lose 2 electrons, right? If 1 electron it lose means 1 plus will come. If 2 electrons it lose means 2 plus will come. Since it is losing 2 electrons, here plus 2 will come, right? Plus 2 electrons, right? Next, what is the another thing over here? Oxygen 8. Oxygen atomic number is 8. Its nearest is 10. So its nearest is 10. It take 2 electrons. To take 2 electrons, which is released by the calcium, and become O2 minus. If you take 1 electron means O minus. If it takes 2 electrons means O2 minus. So we are getting O2 minus here. Now we have positive charge and negative charge both. So there is a development of electrostatic attraction. There is electrostatic attraction. You can also represent this, right? These calcium 2 electrons will be taken up by the oxygen molecule. That means transfer of electrons is happening. In such a way, ionic bond formation takes place. If you check the properties of the ionic compounds, right? If you check the properties of the ionic compounds, properties of ionic compounds, and ionic compounds all are solids, right? Ionic compounds all are solids. If you take NaCl, sodium chloride, daily we are using. that is a solid. Ionic compounds all are solids, and they have high melting and boiling points. They have high melting and boiling points. So if you want to melt NaCl means you need to go above 1000 degrees temperature like that. That means, now I'm not sure, roughly I'm telling, above 1000 degrees centigrade we need to go like that. So that means they have high melting and boiling points. They have high melting and boiling points, right? They are solids, they have high melting and boiling points, right? They are soluble in water. Ionic compounds are soluble in water. Ionic compounds are soluble. Why these are solids? There is a strong electrostatic force of attraction. If there are strong electrostatic force of attraction means they are held together. If they are held together means it forms solid, right? There is a weak force of attraction. They are held far away. They are held themselves far away. Held themselves far away means these are gases. Those are gases. So, but here because of the strong electrostatic force of attraction, they become very close. That's why these are solids, right? So they are soluble in water, and very important point, in solid state they do not conduct electricity. In solid state they do not conduct electricity. This is very important point. In solid state they do not conduct electricity, but in molten fusion or aqueous state they conduct electricity. Right? So in molten or fusion state means NaCl, if you heat by heating at what particular temperature, it will become liquid. If you heat NaCl by heating at a particular temperature, it will become liquid. That is molten or fusion state. What is aqueous state? If you take some salt and add it to the water, it's soluble in water and become liquid. That is called aqueous state. I think you understood what is the difference between the molten and aqueous state. Molten state means a solid will be converted to liquid by heating. Aqueous state means solid will be converted to liquid by adding it to the water, right? In solid state, solid NaCl doesn't conduct electricity, but molten or fusion state, they conduct electricity. Why? Because conduction of electricity required movement of ions, right? Conduction of electricity requires movement of ions. In solid state, they are held by strong electrostatic forces of attraction, so ions are not at all moving. Ions are not at all movable, right? So when liquid state, liquid means there is flow of ions are there. Electricity needs flow of ions. In liquid or aqueous state means there is a flow of ions. That's why in liquid state they conduct electricity, but in solid state they doesn't conduct electricity. So these are the important properties of the ionic ion. And I will also explain one more point: conditions for the formation of ionic bond. Conditions for the formation of ionic bond. I'll explain you here. Conditions for formation of ionic bond. Conditions for the formation of ionic bond. To form the ionic bond, right? Ionization potential. IP means ionization potential of the element right? Ionization potential of the one element or metal. Ionization potential of the metal is low. So to form the ionic bond, ionization potential of the metal is low. If ionization potential of the metal is low means it easily releases electron, right? So electron transfer happens very easily. What is ionization potential? That I will explain in periodic properties. Now you just understood. Ionization potential of metal is low means it releases electrons easily, right? So that will be taken up by the non-metal easily. If metal releases electron easily, non-metal will take it easily, right? That's why ionization potential of metal is low means it releases electron easily. So that's why for the condition for the formation of ionic bond, ionization potential of element should be low. and electron affinity, EA means electron affinity of non-metal, electron affinity of non-metal is high. Right? Electron affinity of non-metal means high, means it will easily, if high electron affinity means it will easily taken up the electron. If electron affinity high means it will easily taken up the electron. Ionic, since ionic bond is a transfer of the electron, if electron affinity of non-metal is high means it will easily take electron. It will easily take electron. So transfer of electron happens. So there is a formation of ionic bond. As we know, generally chemical bonding is majorly of three types, right? Ionic, covalent, okay, ionic, covalent, and covalent bonds. Ionic, covalent, and covalent bonds. So we have already discussed about the ionic compounds. Coming to the covalent bond, right? Coming to the covalent bond. Covalent bond formed by sharing the electrons, right? By sharing the electrons. So ionic bond formed by the transfer of the electrons. Ionic bond formed by the transfer of the electrons. If you take NaCl, if you take ionic bond, if you take NaCl, right? So in ionic bond, what is happening? Na is becoming Na plus and electron, right? This Cl is taking this electron and it becomes Cl minus. I repeat, in ionic compound NaCl, what is happening? Na is losing electron and become Na plus electron. The electron released by the sodium, the electron which is released by the sodium taken up by the chlorine and it will become Cl minus. So electron is transferring from sodium to chlorine. Electron is transferring from sodium to chlorine. So ionic bond formed by the transfer of the electron from one element to the another element, but covalent bond formed by the sharing of the electrons. Right? Now I will show you how the electrons will be shared in covalent bond. I will show you now how the electrons will be shared in covalent bond. Right? If you take element hydrogen, right? Hydrogen. So what is the bonding present between the hydrogen? That we will find now. Right? If you take hydrogen electronic configuration is, right? If you take two hydrogen atoms, right? Hydrogen means how many hydrogen atoms are there? Two hydrogen atoms. H2, how many hydrogen atoms are there? Two hydrogen atom. Hydrogen atom electronic configuration is 1. Atomic number is 1. Hydrogen atom atomic number is 1. That means it has one electron. So that one electron I will write like this. Okay. So hydrogen atomic number, in hydrogen molecule there are two hydrogen atoms. Hydrogen atomic number is 1. So it contains one electron. I am writing the electrons like this. Okay. Now what will happen? So we know that the electronic configurations 2, 8, 10, 18, right? The electronic configurations 2, 8, 10, 18 are the atomic numbers with 2, 8, 10, 18 are stable. So by losing or gaining, by losing the electron or by gaining the electron or by sharing the electron, all atoms try to get these numbers, either 2, 8, 10 or 18. If you see NaCl atomic number is 1. Sodium atomic number is 11. By losing one electron, sodium is becoming 10. Right? If you take NaCl, right? Here, sodium atomic number is 11. By losing the one electron, it tried to become 10. In chlorine, atomic number is 17. By gaining one electron, it's tried to become 18. Right? So, in ionic compound, what is happening? By losing or gaining electron, they will try to become stable. In covalent bonding, what is happen? By sharing the electrons, they will try to this electronic configuration to get them stable, but to get by themselves stable. If you take hydrogen, right? If you take hydrogen, in hydrogen there is one electron. So what is the nearest number to hydrogen? 2. What is the nearest number to hydrogen? 2. So by sharing the two electrons, right? By sharing the two electrons in such a way, observe carefully here. by sharing the 2 electrons in such a way, right? So covalent bond will be formed. So we can represent the hydrogen like this. I repeat. So atoms by losing electrons or gaining electrons or by sharing the electrons always try themselves to become stable, right? So if you take hydrogen here, hydrogen atomic number is 1, so it has 1 electron, right? So in hydrogen there are 2 atoms, so I represent like this, each hydrogen with 1 electron, right? So 2 is stable, so by sharing the 2 electrons, right? So while counting, after sharing you need to count like this. After sharing you need to count like this. For this hydrogen 2 electrons, so 2 it becomes stable. For this hydrogen you need to count like this, 2 electrons, so this is 2. So in such a way, right, covalent bond will be formed. We will do some more examples now. Okay. Now I will show the covalent bonding in oxygen, right? The covalent bonding in oxygen. Generally take oxygen, right? Oxygen atomic number is 8. Oxygen atomic number is 8. Its electronic configuration is 2, 6. Electronic configuration is 2, 6. Always we need to take valence shell electrons only. Always we need to take valence electron only. We are not supposed to take the inner shell electrons. So how many electrons are there for oxygen? 6 electrons. So I will represent like this. 1, 2, 3, 4, 5, 6. You can use dots also, right? You can use dots also. So what are the electronic configurations stable? 2, 8, 10, 18 are stable. 2, 8, 10, 18 are stable. So here there are 6. It needs 2 more electrons. It needs 2 more electrons to become stable. So to get 8, it needs 2 more electrons to become stable. So the 2 more electrons, so it takes from another oxygen atom. It takes from another oxygen atom. If you take another oxygen atom, so if you write the electrons like this, right? So 6 electrons. 6 electrons. Now observe carefully how I am drawing the circle. So oxygen needs 8 electrons. Oxygen needs 8 electrons to become stable. Then go 1, 2, 3, 4, 5, 6, 7, 8. So draw the circle for this 8 electrons. Observe carefully. Draw the circle for this 8 electrons. Okay. Draw the circle for this 8 electrons. Oxygen. Now if you check this oxygen, right? Now if you check this oxygen, so it also needs, this oxygen gained 8 electrons, right? This oxygen also need 2 more electrons to become stable itself. This oxygen also need 2 more electrons to become stable itself. So 1, 2, 3, 4, 5, 6, 7, 8. So draw a circle like this. Okay, draw a circle like this. Understood? So now while calculating the electron, first close this oxygen. While calculating the electrons for this oxygen, first close this and count the electrons in the circle only. Count the electrons in the circle only. 1, 2, 3, 4, 5, 6, 7, 8. Count the electrons in this complete circle, 8 electrons. So this oxygen becomes stable. If you come over here, take this oxygen, count the electrons belonging to this circle only. Take this oxygen, count the electrons belonging to this circle only. How many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Right? In such a way, there is a covalent bond formed between the 2 oxygen molecules, right? And the bonding between the 2 oxygen atoms is covalent bond, right? Then I will do for nitrogen. Okay. Then I will do for nitrogen. So nitrogen atomic number is 7. Nitrogen atomic number is 7. So electronic configuration is 2, 5. Electronic configuration is 2, 5. So if you represent the electrons, so I will represent like this. 1, 2, 3. So if you take nitrogen over here, so 1, 2, 3 like this. So I represented the outer shell electrons. How many outer shell electrons are there? 5. So I represented like this. Right? So now to get the stable electronic configuration, right? So nitrogen need 8 electrons. To get the stable electronic configuration, nitrogen need 8 electrons. So draw a circle that covers the 8 electrons. Draw the circle around the nitrogen that covers the 8 electrons. See here 1, 2, 3, 4, 5, 6, 7, 8. So I am going to draw the circle over here. right? So how many electrons for this nitrogen? 8 electrons. For this nitrogen also the same will come. For this nitrogen also the same will come. So for comparison purpose, I am now writing for the hydrogen molecule. For comparison purpose, now I am writing for the hydrogen molecule. If you take the hydrogen H, atomic number is 1. So it has electronic configuration is 1, right? So it has 1 electron. So a hydrogen has 1 electron. It will take another electron from another hydrogen molecule to become 2, to become stable 2, right? So how the circle we need to draw here? So by taking the 2 electrons. Here also, this hydrogen also, we need to draw the circle like this. You have observed here carefully. Observe here carefully. Here only 2 electrons are involving. 2 electrons are involving. So here single bond will come. Here 2 electrons are involving. Only one pair is coming. One pair electrons are involving. One pair of electrons are involving. So single bond will come. If you take oxygen over here, 2 pairs of electrons are involving. If you take oxygen over here, 2 pairs of electrons are involving. So here O double bond O will come. Here O double bond O will come. If you take nitrogen here, 3 pairs of electrons are involving. In here 3 pairs of electrons are involving. So N triple bond N will come. I think covalent bond may be single bond or double bond or triple bond. But ionic bond always electrostatic attraction, but covalent bond will be single bond or double bond or triple bond. Here single bond present between the 2 hydrogen atoms. Between 2 oxygen atoms there is the presence of double bond. Between nitrogen atoms there is a presence of triple bond. Now I will solve the question for some more atoms, some more molecules, then you will get very clear idea, right? Kindly observe. Now I will do it for CH4 molecule, right? I will do for CH4 molecule. If you take CH4 molecule, that is a methane. CH4 is nothing but that's a methane. Methane molecule, if you show how the covalent bond will form, right? Or how the Lewis dot structure, these structures are also called Lewis dot structures. These structures are also called Lewis dot structures. If you take methane molecule, CH4, okay. So I am going to show the covalent bond in this molecule, right? First write carbon, right? Carbon atomic number is 6. Carbon atomic number is 6. Its electronic configuration is 2, 4. Its electronic configuration is 2, 4, right? And now artificial how many electrons are there? 4 electrons are there. So write 4 electrons. 1, 2, 3, 4. Right? 4 electrons. So how many hydrogens are there? 4 hydrogen. How many hydrogens are there? 4 hydrogen. Each hydrogen carries single electron. We know each hydrogen carries single electron. So write hydrogens over here. Okay. H, right? H. Okay. So 4 hydrogens I have written over there. I repeat, carbon atomic number is 6, its electronic configuration is 2, 4. That's why around carbon I have written 4 electrons. As we know, hydrogen atomic number is 1, it has 1 electron, so I have written 4 electrons over here. Now, what are the stable electronic configurations we have? 2, 8, 10, 18, right? 2, 8, 10, 18, these are the stable electronic configurations we have. So here, 4, the radiation number is 8. So carbon, it has 4 electrons, so the radius number is 8. So how we need to draw the circle? To that the circle that is covering 8 electrons. How we need to draw the circle? The circle that is going to be covered 8 electrons. So here I am going to draw the circle 1, 2, 3, 4, 5, 6, 7, 8. That means like this it will come. Okay, like this it will come. If you count 1, 2, 3, 4, 5, 6, 7, 8. For hydrogen, nearest number is 2, so it is going to be share. It is going to get 1 electron from carbon. Hydrogen has already 1 electron. To get the 2, it is going to get 1 electron from carbon. So for hydrogen 2 electrons, we need to draw like this. Here we need to draw like this. Here we are going to draw like this. Here also we are going to draw like this. Here how many electrons is going to? Only 2 electrons. 1 pair of electron is sharing over here. That's why single bond will come. So if you write the bonding over here, C H, 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 H. So this is the covalent bonding structure of the methane. We'll simply write CH4, right? Now I will show you for CO2 molecule, right? Carbon dioxide molecule I will show you, right? Then it will be very clear to you, right? How to write the covalent bonding, that will be very clear to you. Now I will write for CO2 molecule. Okay. If you take CO2 molecule, right? Take CO2 molecule. First write carbon, right? Carbon atomic number is 6. It has how many? What is the electronic configuration? 2, 4. So write 4 electrons for carbon. So now carbon part is over. Carbon part is over. Now we need to write for the oxygen, right? Oxygen atomic number is 8. Its electronic configuration is 2, 6. Oxygen atomic number is 8. Its electronic configuration is 2, 6. There are how many electrons in the valence shell? 6. So these 2 I am not going to consider. Why? Because I always need to take the electrons in the valence shell only. So I will write oxygen over here, right? I will write 6 electrons. Oxygen has 6 electrons. I will take one more oxygen over here. Why? In CO2 molecule there are 2 oxygen atoms. That's why I am taking one more oxygen atom here. So I am going to write 6 electrons over here, right? So we need now oxygen. We need to draw the circle. We need to draw the circle that each element is going to get 8 electrons. Each element is going to get 8 electrons. That is also called octet rule, right? That is also called octet rule. That is more stable. So here, first now I am going to draw the circle that which it covers 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So I am going to draw the circle like this. This is the first one, right? So for this oxygen also the circle will come 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now the carbon atom, it needs 8 electrons. It also needs 8 electrons. Already 4 electrons are there. 1, 2, 3, 4. Carbon will take up these 2 electrons also. Carbon will take up these 2 electrons from oxygen and these 2 electrons from oxygen to become total 8. Carbon has already 4. Carbon will take 2 electrons from this oxygen and 2 electrons from this oxygen, from another oxygen, and finally also it will become 8. So we need to draw the circle like this. We need to draw the circle like this. Okay. Now, so first here O, first write O, right? So how many electrons are going to be shared here? How many electrons? 2 pairs of electrons. So double bond will come, right? Then again write C. How many electrons are going to be shared over here? Right? 2 pairs. So double bond will come. So O, right? So the structure of the CO2 molecule covalent bond is O double bond, CO double bond O, that we directly write CO2, right? So the electrons which are not involved in sharing, one more important point I am covering here. The electrons which are not involved in sharing, we can represent like this. So see here these 2 electron pairs, not at all involved in sharing. Here these 2 electron pairs not at all involved in sharing, so I am writing as such. Here also these 2 electrons are not at all involved in the sharing, so I am writing as such. This is the exact Lewis dot structure of the carbon dioxide molecule, CO2 molecule. Understood now? So I will do for one more molecule for you, right? I will do one more molecule, that is, I have showed you for methane, right? So comparatively I will explain you, right? Then you will get very clear idea on how to write those compounds, right? If you take CH4 and if you take C2H2 here, C2H4 here and C2H2 here, right? So now we are going to write the Lewis dot structure for these molecules and how the covalent bond is involving. That we are going to write over here. First write the carbon. What is the atomic number? 6. Electronic configuration is 2, 4. Electronic configuration is 2, 4. So there are 4 electrons around the carbon. 4 electrons around the carbon. Hydrogen atomic number is 1. I am writing here. hydrogen atomic number is 1, right? So electronic configuration is also 1. So hydrogen has 1 electron. Hydrogen has 1 electron, right? So the circle will become like this, right? Why carbon has 8 electrons? So the circle will become like this. For hydrogens, the circle will become like this. Why? Because by getting duplet, hydrogen will become stable. That's why this circle is enough, right? For this hydrogen, this circle, right? This circle, only one pair of electrons are sharing. That's why the structure of the methane will come like this. The structure of the methane will come like this. Now we will write for the C2H4. Now we are going to find the covalent bonding nature. So covalent Lewis dot structure or covalent bonding nature in ethene, that is C2H4. First write carbon, right? Carbon atomic number is 6, so it has electrons 4. Electronic configuration is 2, 4. Carbon atomic number is 6, it has 6 electrons. Electronic configuration is 2, 4. So carbon has 4 electrons. So write 4 electrons for the carbon, right? So write 4 electrons for the carbon atom, right? So we have another carbon. So for that carbon also we have 4 electrons. We have how many hydrogens? 4 hydrogens. Each hydrogen has single electron. So I am going to write the hydrogens over here like this. Okay, I am going to write the hydrogens over here like this. Now, so this hydrogen will get duplet. This hydrogen will get stable by duplet. That means by taking, so hydrogen 2 electrons. So in the circle, we need to make a circle like that. Hydrogen has 2 electrons to become stable, right? So here also hydrogen 2 electrons. Hydrogen 2 electrons. For carbon, it needs 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So for this carbon, the circle will come like this. Observe carefully. For this carbon, 1, 2, 3, 4, 5, 6, 7, 8. So the circle will come like this. Okay. For this carbon, the circle will come like this. For this carbon, the circle will come like this. Okay. For this carbon, the circle will come like this. So if you count individually, so for this carbon close in this circle only. For this carbon, count the electrons in that circle only, right? This carbon, if you count 1, 2, 3, 4, 5, 6, 7, 8. So it is stable. For this carbon, count the electrons in this circle only. For this carbon, count the electrons in this circle only. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So here hydrogen. So close this. In that circle, hydrogen count 2 electrons. In this circle, count for hydrogen 2 electrons. Same way there also. So now I will write the structure C. Here one pair is sharing. So CH. Here also one pair is sharing. CH. Here 2 pairs are sharing. So 2 electron pairs are sharing between 2 carbons. 2 electron pairs are sharing between 2 carbons. So double bond will come here, single bond and single bond. This is the structure of the C2H4 molecule, right? So for C2H2 molecules also I will show you now, right? For C2H2 molecule, just write first, as you know, right? Carbon has 4 electrons. As you know, carbon has 4 electrons. I am representing the 4 electrons like this. Carbon has 4 electrons. I am representing the electrons like this. If you take this carbon also, it has 4 electrons. I am representing it like this. So each hydrogen with 1 electron, right? Here also hydrogen with 1 electron. Now we need to draw the circle that each carbon contains 8 electrons. So I will draw the circle like this: 3, 3, 6, 8. Okay. I will draw the circle like this. If you count for carbon, see 3, 3, 6, 2, 8. Right? So for this carbon, the circle will come like this. Hydrogens like this. Okay. Understand carefully. So or else I will rub that one and I will explain you here to understand it better. So I am going to rub this and I am going to explain the acetylene molecule over here. Okay. If you take acetylene molecule C2H2, right? I am rubbing this for your better understanding. So I am rubbing and writing over here C2H2, right? Each carbon atomic number is 6. So it has the electronic configuration is 2, 4. right? There are 2 carbons. So I am writing the 4 electrons like this, right? 4 electrons like this, 4 electrons like this. There are 2 hydrogens. For hydrogen, I am writing like this. So now next step is we need to draw the circle that each carbon covers 8 electrons. So I will take this carbon 1, 2, 3, 3, 3, 6, 2, 8. So 3, these 3, 6, this 2, 8. So I am going to draw the circle like this. Okay, I am going to draw the circle like this. Now see, this carbon has 8 electrons. 3, 3, 6, this one 2. So for another carbon, how the circle will come? Another carbon, the circle will come like this. For hydrogens, the circle will come like this. For this hydrogen, the circle will come like this. Now see, between the carbon and hydrogen, only one pair of electrons are sharing. So we can write Hc. So between the two carbons, there are 3 pairs of electrons are sharing. So we can write C. Okay. So between carbon and hydrogen, one pair of electron is only sharing. So we can write CH triple bond CH for acetylene molecule. Now understood, right? Now I will write the structures of the 3. Right? Directly I will write the structures of the 3 now. Okay. CH4 and C2H4 and C2H2. So the CH4 structure is H. The C2H4 structure is CH2 double bond CH2. The acetylene structure is CH triple bond CH. So in such a way, we can write the structure of the organic compounds. So finally, I will write for one molecule, write one more molecule. Then you will get very, very clear idea. If you take CCl4, right? If you take CCl4, okay, first take the carbon. Carbon atomic number is 6. It has electrons 2, 4. So there are 4 electrons per carbon. So write like this. And take chlorine over here. The electronic configuration is 7. Its atomic number is 17. Electronic configuration is 2, 8, right? 2, 8, 7. Its electronic configuration is 2, 8, 7. So in valence shell, how many electrons are there for chlorine? In valence shell, this is the valence shell. How many electrons are there? 7 electrons. So I am going to write like this. Right? In valence electron, for there are chlorine 7 electrons. So 1, 2, 3, 4, 5, 6, 7 I have written. Here also I will write 7 electrons. Here also I will write 7 electrons. Okay. So 1, 2, 3, 4, 5, 6, 7. Right? Now we need to make the circle that is so that each element get 8 electrons. So carbon, how circle will come? So 1, 2, 3, 4, 5, 6. So one more chlorine atom is there, right? So one more chlorine atom is there. I will write one more chlorine atom over here. Okay. Now circle. So carbon has 4 electrons, and carbon will also take these 4 electrons. Okay. Now carbon has 8 electrons. Chlorine, how it will circle, how it will come? Already there are 6 electrons for chlorine. So and chlorine will take these 2 electrons. Already there are 6 electrons for chlorine. So it also need to get 8 electrons. So these 2 electrons will chlorine will take. So I will make the circle like this. And make sure that each circle, if you count hydrogen, 2 electrons. Hydrogen, if it is in circle, you are making circle, make sure that hydrogen in that circle having 2 electrons. Any other element, make sure that if you are going to draw a circle, in that circle, make sure that each element is having 8 electrons. Okay. So here, chlorine, how it will come? So circle this will come like this. So for this chlorine, circle will come like this. For this chlorine, circle will come like this. Okay. Now draw the over here. So C, there is only one pair of electrons between the carbon and chlorine. There is only one pair of electrons between the carbon and chlorine. Single bond will come. Right? So Cl. So I told you, the electron pairs which are not involved in the reaction, we can write as it is. The electron pairs which are not involved in the reaction, we can represent them as it is. So we can write here Cl has 3 electrons. Here also Cl has 3 electrons. Right? These are 3 electron pairs. Here also Cl has 3 electron pairs. In such a way, we can write the covalent. We can show the covalent bonding nature in how the covalent bond will be formed in CCl4. The CCl4 will be called carbon tetrachloride. And I am giving the homework question, so you can do it for CS2. CO2 I have showed you. CO2 I have showed you. You can solve this for CS2. CS2 is carbon disulfide. Now I will explain the organic properties, right? Properties of the ionic and covalent compounds by comparison, right? Properties of the covalent compounds. I will explain you the properties of covalent compounds, right? So coming to the properties, comparatively I will explain you. So in this section here I will take ionic, here I will take covalent, here I will take covalent, right? First, ionic compounds all are generally solids. Ionic compounds are solids. Covalent compounds may be solids, some are solids, liquids, some are gases also, right? Ionic compounds are solids, covalent compounds some are solids, liquids and gases also. So ionic compounds having high melting and boiling points. Ionic compounds having high melting and boiling points. Why? Because the electrostatic force of attraction is very strong between the cation and anion. Right? The electrostatic force of attraction is very strong between the cation and anion. So ionic compounds have high melting and boiling points, but covalent compounds generally have low melting and boiling points. But covalent compounds generally have low melting and boiling points. So ionic compounds generally soluble in water. Ionic compounds generally soluble in water. Some covalent compounds, right? Some are soluble in water. In covalent compounds we have two types. In covalent compounds we have generally two types: polar or non-polar, right? Polar or non-polar. So polar compounds generally soluble in water. Non-polar compounds insoluble in water. Insoluble in water. So all ionic compounds are soluble in water. In covalent we have generally two: polar and non-polar. Polar covalent compounds are soluble in water and non-polar compounds are insoluble in water. So non-polar compounds generally soluble in organic solvents, right? Non-polar compounds generally soluble in organic solvents. Now, while coming to the conduction of electricity, these are good conductors of, right? In molten or aqueous state, in solid state they won't conduct electricity. In solid state, ionic compounds they won't conduct electricity. In molten or aqueous state, what is the difference between the molten and aqueous state? Molten means directly by heating directly we are converting the solid into liquid. Aqueous means we are making that one liquid by adding the water to it. If solid NaCl is there, if you heat it, by heating it will become liquid, means that is molten. If you take NaCl and if you add it to the water, then also it will become liquid, that is aqueous. Aqueous means there must be presence of water. Aqueous means there must be presence of water. So in molten and aqueous state, they are good conductors of electricity, right? They are good conductors of electricity, right? So here generally the covalent compounds are bad conductors of electricity. Bad conductors of electricity. These covalent compounds are bad conductors of electricity. Now I will show you the conditions for the formation of ionic and covalent bonds. I will brief you this one. Ionic compounds are solids, covalent may be solids, liquids are gases. So ionic compounds generally contain high melting and boiling points. The covalent compound shows low melting and boiling points. Ionic compounds are soluble in water. Covalent compounds generally there are polar and non-polar will be there. Polar covalent compounds are generally soluble in water and non-polar covalent compounds are insoluble in water. So ionic compounds are good conductors of electricity, but covalent compounds are bad conductors of electricity. Now I will show you conditions for the comparatively. I will show you conditions for the formation of ionic bond and covalent bond, right? Comparatively, I will explain you conditions for the formation of ionic and covalent bond, right? So conditions I will show. Write the conditions over here, right? Conditions. So here ionic bond. Here Here covalent bond. Ionic bond and covalent bond. First we will discuss about the size. Right? First we will discuss about the size. So if you come to the size, cation size is large and anion size is small. In such a cases, ionic bond will be formed. Right? If you take NaCl, right? NaCl. So the size of the sodium cation is more. That I am going to explain you in periodic properties. Don't worry, that I am going to explain in periodic properties. If you take NaCl, so sodium cation size is large, chlorine anion size is small. So if size of the cation is large, size of the anion is small, ionic bond will be formed. So here what will happen in covalent bond? The cation size is small. If the anion size is large, so polarization happens, right? So covalent bond, if cation size is small, anion size is large, then polarization happens. If polarization happens means the extent of overlapping is more. So the extent of overlapping is more means sharing of electrons is more. That's why if the cation size is small, if anion size is large, the formation of covalent bond is favorable, right? For small cation size and large anion size, the formation of covalent bond formation is favorable. And coming to the ionization potential, right? Ionization potential. So for the ionic bond, the cation with low ionization potential, right? Low ionization potential, and anion with highest electron affinity, right? Highest electron affinity will favors the ionic bond formation. We are coming to the ionization potential. This also I am going to explain in periodic properties. For now this class, remember, for cation with low ionization potential and anion with high electron affinity, it involves in the formation of ionic bond. Their reverse will happen, right? So here cation with high ionization potential, right? High ionization potential, and anion with lowest electron affinity, right? Lowest electron affinity will result in the formation of covalent bond, right? So ionic bond happens for the transfer of the electrons, and covalent bond happens because of the sharing of the electrons, right? So this is just electrostatic attraction. Covalent bond may be single bond, double bond, or triple bond. Now I am going to explain coordinate covalent bond, right? Coordinate covalent bond. Right, coordinate covalent bond, right? Coordinate covalent bond, generally it will be represented by arrow mark. Coordinate covalent bond will be represented by arrow mark. Why I will show you, right? I will take two molecules. These two molecules I am going to take an example, right? These two molecules, these two compound ions, right? This is a compound. It has charge. That's why I am calling them as compound ions. These compound ions, I am going to take the example to explain the coordinate covalent bond. What I will tell you, so this is very simple. Why? Because if there is any compound molecule, with charge upon it, if any compound molecule, not like single molecules, right? Not like single molecules means sodium plus, right? Or if you take Mg2 plus, right? These are single molecules charge upon it. Not like that. Compound molecules charge upon them. It is there means there must be maximum 90% existence of coordinate covalent bond. So blindly you can remember 90% there is existence of coordinate covalent bond. So for this, so I am taking the H plus out to explain this concept clearly. I am taking the H plus out and I will write like this: NH3 H plus, right? So here also I will write like this. I am taking the H plus out first to make you understand better. I am taking the H plus out and I will explain you now. First write the Lewis dot structure for NH3. So first write the Lewis dot structure for NH3. If you write the Lewis dot structure for NH3, so it will come like this, right? If you write I have already shown you how to write. That's why I am not explaining here, right? So For nitrogen, if you write the Lewis dot structure, it will come like this. Generally, hydrogen has one electron. Generally, hydrogen has one electron. So H plus means that single electron also won't be there, right? Generally, hydrogen has one electron. So if H plus means that one electron also not there, so that's why I am representing it here with empty box, right? This is empty box. Why I am writing empty box here? Hydrogen has one electron. H plus means that electron also will be gone. So H plus has no electrons. That's why I am writing here empty box. So what will happen here? This electron pair will be donated to this H plus ion. That's why we are showing the arrow mark. That's why we are showing here arrow mark. So the electron pair on the nitrogen will be donated to vacant H plus ion. So this is the coordinate covalent bond, right? It is different from ionic and covalent bond. This is coordinate covalent bond. So for the presence of coordinate covalent bond, there must be one pair of electron. There must be one pair of electron and vacant orbital. So there must be one pair of electron in one species, and for another species there must be vacant orbital. If you take H2O plus, if you write the Lewis dot structure for H2O, right? If you write the Lewis dot structure for H2O, it will come like this. And H plus has vacant orbital, right? Vacant orbital, right? So what will happen here? So one of the lone pair will be donated to H plus ion. One of the lone pair on oxygen atom will be donated to H plus ion. So in such a way, coordinate covalent bond will be formed. Covalent compounds are of two types. Polar covalent compounds, right? And non-polar covalent compounds. Ionic compounds always polar. Remember, ionic compounds always polar, but while coming to the covalent compounds, there are polar covalent compounds and non-polar covalent compounds, right? So by looking at the molecule itself, I will give you a hint, I will give you a tip. By looking at the molecule itself, you can identify whether the compound is polar or it belongs to non-polar. So to understand the polar and non-polar, first we need to know about the electronegativity, right? So first we need to know about the electronegativity. If electronegativity difference between the two molecules, if electronegativity difference between the two elements is more, then those compounds are polar compounds. If electronegativity difference between the two elements is less, those compounds belongs to non-polar compounds. I repeat, if electronegativity difference between the two elements is more, those belongs to polar compounds. If electronegativity difference between the two elements is less, those belongs to non-polar compounds. How can we identify the electronegativity difference, right? So how can we identify? I will give the order. First of all, what is electronegativity? If you take covalent molecule, right? If you take a covalent molecule, right? So this is a covalent molecule and this is a covalent bond. This is a covalent molecule and there is a covalent bond. If you take HCl also, right? If you take HCl also, right? So this is a covalent molecule. Now understand the difference carefully, right? Understand the difference carefully. So first I will explain HCl. So comparatively H and Cl, Cl has high electronegativity. What is electronegativity? The tendency to attract a shared pair of electrons. So this is a shared pair of electron. This is hydrogen electron. This is chlorine electron. This is hydrogen electron. This is chlorine electron. So that is sharing. Both are sharing. So this is a shared pair of electron. So electronegativity is the tendency to attract a shared pair of electron. Since here chlorine has high electronegativity. So the shared pair of electron move more towards chlorine. Since chlorine has high electronegativity, the shared pair of electron move more towards chlorine, right? So move towards more chlorine. That's why, right? That's why move more towards chlorine. That's why chlorine will develop a partial negative charge and hydrogen will develop a partial positive charge. I repeat, chlorine has more electronegativity. That's why the shared pair of electron pair move towards chlorine. That's why at chlorine partial negative charge will develop. On hydrogen partial positive charge will develop. Two poles will be formed. One is positive pole, another one is negative pole. That's why HCl is a polar molecule. That's why HCl is a polar molecule. If you take hydrogen, both have same electronegativity. Both equally attracts the electron pair. Both equally attracts the electron pair. That's why there is no formation of poles. No formation of poles. That's why H is a non-polar compound. In such a way, we can identify which compound is polar and which compound is non-polar. So we have the electronegativity order. Based on the order, we can say which molecule is more polar and which molecule is less polar. I am writing the electronegativity order, that is FO, N, Cl, right? Br, I, iodine, sulfur, carbon, hydrogen. So remember this order. While going from fluorine to hydrogen, the electronegativity is decreasing. While going from fluorine to hydrogen, the electronegativity is decreasing. So which compound is more polar? As I already told you, if electronegativity difference is more, that compound is more polar. If you check here, HF, the electronegativity difference is more. HF, the electronegativity difference is more. While it is first, it is last, the difference is more. So HF is more polar. Then if you take oxygen and hydrogen, right? So this is also polar compound. Oxygen, nitrogen, this is also polar compound. If you take nitrogen and hydrogen, the ammonia molecule is there, right? If you take nitrogen and hydrogen, ammonia molecule is there. Among these three, which is more polar? HF. Why? Because the electronegativity difference is more, right? Next, coming to here, H2O and NH3. H2O, which is more polar? H2 is more polar. Why? The electronegativity difference is more O and H compared than N and H. That's why this is the polarity after and electronegativity order. And I will tell if any compound is given. By this, we can say that compound is polar or not. Suppose if anyone asks you whether tell me CO2 is polar or not, you can easily tell. If anyone asks you to tell whether CO2 is polar or not, you can easily tell. See, carbon and oxygen. Electronegativity difference is there. Carbon, oxygen over here, carbon over there. So there is electronegativity difference. That's why CO2 molecule is polar. If anyone asks you whether CH4 molecule is polar or not, it is non-polar. Why? Because C and H side by side is there. So the electronegativity difference is very less. That's why CH4 molecule is a non-polar. There are some exceptions. So maximum 80% we can say whether the molecule is polar or non-polar. There are some exceptions that I will show you. If you take this molecule, right, CCl4 molecule, by looking itself we can identify it is somewhat polar. Why? There is electronegativity difference is there. By looking itself, what we say? It is polar, but it is exceptional compound. If you write the CCl4 structure, so the poles will be developed. The poles are exactly opposite to each other. Since it's a vector quantity, right? So dipole is a vector quantity. So the polarity cancelled out. The polarity will be cancelled out. So that's why CCl4 is a non-polar molecule, right? There are some exceptions for this. 80% we can say whether the molecule is polar or not. To understand you better, I have explained the exception. CCl4 is a non-polar molecule, right? In such a way, we can identify whether the molecule is polar or not polar. Okay. If you check the properties of polar and non-polar compounds, right? Polar compounds generally with high electronegativity difference, right? Polar compounds formed by atoms between high electronegativity difference. Non-polar compounds generally low electronegativity difference, right? No low electronegativity difference. Polar compounds have generally high electronegativity difference between the two atoms. Non-polar compounds low electronegativity difference between the two atoms, right? Generally, polar compounds are soluble in water, right? Generally, polar compounds are soluble in water. Polar compounds are soluble in water, right? Non-polar compounds are insoluble in water. Non-polar compounds are insoluble in water, right? Polar compounds ionize in water. Polar compounds ionize in water. So water make them ionize and they form ions, right? So they form ions. Polar compounds are soluble in water. They undergo ionization in water and they form ions. If you take HCl, it will become H plus and Cl minus ion. If you take any organic solvent like CH4 or CaCl4, those are insoluble in water, right? Insoluble in water. Insoluble in water, right? So ionic compounds dissociates in water. If you take NaCl, so this is an important point. Ionic compounds dissociates in water. Already they are ions. So already ionic compounds, they are already ions. Already ions. If you add them in the water, ions will move freely. That's it. Ionic compounds already ions. If you add them to water, they will move freely. But covalent compound not ion. HCl is a not ion. HCl is a molecule. But when we add this to water, then only ions will become. That's why we call this as ionization, right? HCl, we call this as ionization. NaCl, if we add to water, this is called dissociation, right? I request you students to understand the difference. NaCl means already ionic bond, already ions. If you add them to water, just they will dissociate. That's it. But here HCl is a molecule. HCl is a molecule. After adding to water, that is becoming ions. After adding to HCl, first it is a molecule. After adding to ions, after adding to water, then ions will be generated. After adding to water, then ions will be generated. That's why the term ionization will be used for covalent molecule and dissociation will be used for sodium chloride when we add it to the water. Generally, polar molecules have high melting and boiling points. Generally, polar compounds have high melting and boiling points, right? Generally, polar compounds have high melting and boiling points. Non-polar compounds have low melting and boiling points. Generally, polar compounds have high melting and boiling points. Non-polar compounds have low melting and boiling points. At last, I will show you, right? I told you NaCl is dissociates in water, right? NaCl dissociation happens in water. HCl polarization happens in water, right? NaCl dissociation happens in water. HCl polarization happens in water. That I will show you how a NaCl molecule will dissociate in water. If you take NaCl, it will be dissociated into Na plus and Cl minus ions. Around Na plus ion, there will be surrounding water molecules, right? There will be surrounding water molecules where oxygen faces the sodium cation. Why oxygen faces sodium cation over here? Oxygen has high electronegativity, right? Oxygen has high electronegativity. That's why oxygen faces sodium cation over here. If you take chlorine, it will be surrounded by water molecule, right? And chlorine anion also surrounded by water molecules, but hydrogen faces towards chlorine anion. Why hydrogen is facing chlorine anion? Because chlorine is electronegative, hydrogen is generally electropositive in nature. That's why here hydrogen faces chlorine ion. In the same way, here also H plus and Cl minus ions will be there. So by adding the water molecule, right? By adding HCl to the water, right? So it will ionize into H plus and Cl minus ions, right? Here generally we can say and H plus around Cl minus ions, there is accumulation of water molecule where hydrogen ion faces the chlorine ion. Hydrogen atom faces the chlorine ion, and H plus ions in water also H plus ions are there. right? So just HCl, just keep in mind, NaCl dissociates in water, HCl ionizes in water, right? I hope you enjoy this video. Kindly keep watching on. If you like this video really, kindly like, share and subscribe. Thank you so much.